Hi everyone, this is Dr. Nak and we're going to go over section 8.2, Simplify Radical Expressions. First, let's recall all the properties that we have learned so far from elementary algebra. So properties 1 through 4, I think you've seen those before. You might want to write these out if you want to memorize them. And the new one that we're going to be learning is 5 and 6. So we have nth root of a times b. That's going to equal to nth root of a times the nth root of b. And also, nth root of a over b is nth root of a over nth root of b. Gosh, that's a tongue twister for me. Let's do some examples. Simplify 5 squared times 5. Okay, so if I apply property number 1, this is same thing as 5 squared times 5 to the, there's an invisible 1 sitting there. So this is going to be 5 to the 2 plus 1, which is going to give us 3. So our answer is going to be 125. Part B, 2 to the third to the second power. So in this case, I believe that we can apply property number 2. So this is same thing as 2 to the 3 times 2, which is 2 to the 6. Multiply 2 6 times, what do we get? 64? Oops. So here we're going to get 64 for the answer. Now let's look at 2 to the third to the second power. So if I apply property number 3 to this, what we're going to get is 2 squared divided by 3 squared. So which is going to give us 4 over 9. I'm just reviewing the properties that we have learned so far from elementary algebra. Now let's go with D. Let's go maybe 2 to the 5th over 2 to the 3rd. Okay, so property number 4, here you're going to get 2 to the 5 minus 3, which gives us 2 to the 2nd. So our answer is going to be 4. Let's take a look at another one. So I'm going to go like this. I'm going to flip it. 2 to the 3rd over 2 to the 5th. Okay, so in this case, we're going to do the same thing. 2 to the top exponent minus the bottom exponent. So in this case, what we're going to get is 2 to the negative 2. So remember the properties of the negative exponent. So what's going to happen is you're going to have to flip the base and then attach the positive exponent on the base. So in this case, what we're going to get is 1/4. Okay, now let's look at example 2, simplify square root of 98. Now, how the textbook does problems like this is that since you're given a square root, they want you to find the perfect squared of 98. So 98 is same thing as 49 times 2. Then they want you to apply the property number 5. So here you're going to have square root of 49 times the square root of 2. Remember, 49 is same thing as 7 squared. So we say that 49 is a perfect squared. So this is going to equal to, oops, why is that in red? Sorry. Okay, so this is same thing as 7 times the square root of 2, and that's going to be the answer. Alright, but now let's talk about this. What if I could not find the largest perfect square factor of 98? Okay, because I don't know, how did they come up with 49 times 2 all of a sudden? So in that case, what I would do is this. If you cannot figure out the biggest perfect square, I would just break it down in a prime factor tree. So 98. Well, 2 is going to go in because 98 is even, so 2 times 49. And then here you're going to have 7 times 7. So therefore, let me just write the way I do it in blue. Square root of 98 is same thing as the square root of, let me see, this is 2 times 7 squared. 2 times 7 squared. So this is same thing as square root of 2 times the square root of 7 squared. Now this guy is going to become 7, and then square root of 2 So, but we usually write the square root after the whole number, so we're still gonna get 7 square root of 2 for the answer. So you can always use this method if you cannot figure it out what the biggest perfect square factor is, or perfect cube, perfect fourth, and so forth. Let's take a look at square root of 500. Okay, so I'm not quite sure what the biggest perfect square is, so I'm going to break it down. So I'm going to take 500, and that's same thing as 5 times 100, and 100 is same thing as 10 times 10. Great. So 500 is 10 squared times 5. Do you see why I'm looking for the second power? It's because I'm given a square root. If I'm given the square root, what I'm looking for is a perfect squared. If I'm given the cube root, then I'll be looking for perfect cube number. But anyways, let me just break this up into 10 squared times 5. Now notice that this is going to be a perfect squared. So this is same thing as the square root of 10 squared times the square root of 5. So our answer is going to be 10 square root of 5. Okay, now let's look at square root of 432. So again, I cannot figure it out what the biggest perfect square factor of 432 is, so I'm just going to break it down. So 432, since it's an even number, 2 is going to go in. So what's 432 divided by 2? 216. All right, now that's still even, so for sure 2 is going to go in. So what is that? 2 times 108? Goodness. All right, now 108 is still an even number, so here we go. 2 times 54. And 54 is still even. So 2 is going to go in. And 2 times, what is 54? 27. And then here you're going to have 3 times 9, then 3 and a 3. Okay, so what I just did was I just basically broke down 432 into all prime numbers. So here you're going to have 2 to the, how many 2's do we got going on? 1, 2, 3, 4. 2 to the 4th times 3 to the 1, 2, 3. 3 to the 3rd. Now let me rewrite this as square root of 2 to the 4th times 3 to the 3rd. But remember, I'm given the square root. So what I'm looking for is perfect square. So I'm going to break down the exponent into a power of 2. So 2 to the 4th is same thing as 2 squared times 2 squared. Remember, you add the exponents. So if I add 2 plus 2, it's going to give us 4. And then I could break down 3 to the 3rd into 3 squared times 3 to the 1st. Because again, you add the exponents. So now let me just circle the perfect square. This guy is perfect, perfect, perfect squared. Okay, so then think of it, you can do this in your head, because next step you're going to break this apart into square root of 2 squared, square root of 2 squared, square root of 3 squared times the square root of 3. Okay, so you don't have to write this portion out if you don't want to. So in this case here, you're going to get 2 times 2 times 3 times square root of 3. So in this case, we're going to have 2 times 2 is 4. 4 times 3 is 12. So it looks like our answer is going to be 12 root 3. Let's do another square root. So let's take a look at square root of 288. So again, I'm going to break this down into product of primes because I can't figure it out what the biggest perfect square factor is in 288. So 288, all right, that guy's even. So 2 is going to go in. And rest is 144. That guy is still even, so 2 is going to go in. 2 times 72. Ah, goodness, it's still even. So here you're going to have 2 times 36. And then looks like we're gonna have 6 and a 6. And you could stop here if you want to, but suppose you didn't see it and you just want to break it up. 2 times 3 and then 2 times 3. Okay, so if I write 288, this is gonna be 2 to the, how many 2's do we have? 1, 2, 3, 4, 5. 2 to the 5th times 3 to the, how many 3's do we have? 3 squared. Alright, so now I'm gonna come back over here and I'm gonna rewrite this guy as 2 to the 5th times 3 squared. Okay, but since I'm given the square root, I need to break this up into maybe 2 squared times 2 to the 3rd times 3 squared. Alright, do you notice something? I could still break down 2 cubed, 2 to the 3rd power. So you get 2 squared times, alright, now I'm going to break this guy up into 2 squared times 2 to the 1st because you add exponents. And then here you're going to have 3 squared. Sorry, I'm doing this step by step by step. So now I'm going to circle the perfect ones, perfect squares. Alright, now this is going to be same thing as 2 times 3 times square root of 2. Now this 2 comes from square root of 2 squared, and this one is also from square root of 2 squared, and then this 3 is from square root of 3 squared. And poor 2 is left under the radical sign. So again, 2 times 2 is 4, 4 times 3 is 12. So you're gonna have 12 square root of 2. It looks like that's gonna be our answer. Okay, now let's move on to cube root. So let's first try cube root of 81. So now, since we're given the cube root, what we're looking for is perfectly cubed number. So again, I really cannot figure that out, so I'm going to break it down. So I'm going to go 81. What gives 81? 9 and a 9. And 3, 3. And 3, 3. So it looks like 81 is 3 to the 4th power. Break it down. So now I'm going to have cube root of 3 to the 4th. But I'm looking for perfect cube. So what we need to do now is you need to break down 3 to the 4th into cube root of 3 to the 3rd times 3 to the 1st. Again, we add the exponents. So if I have 3 to the 3rd times 3 to the 1st, we're going to get 3 to the 4th back. Now let's circle the perfect cube. Here we go. So if I have to do this step by step, this is same thing as cube root of 3 to the 3rd. Dang, there are too many 3's flying around. And then cube root of 3 to the 1st. So again, this is going to become, this is going to become 3 times cube root of 3. My goodness, it's all 3, 3, 3, 3, 3. Everywhere is 3. Alright, so that's going to be our answer. Let's do another cube root. Let's take a look at cube root of 625. Again, since we're given the cube root, what we're looking for is a perfect cube factor in 625. So keep that in mind, and I'm going to break it down because I can't figure it out. So 625, definitely 5 is going to go in there. So 625 divided by 5 gives 125. And again, 5 is going to go in, so you're going to have 5 times the 25. And then here you're going to have 5 times the 5. And we're done. Not done, but we're done breaking down 625 into product of primes. So here you're going to have 5 to the 4th power. Now I'm going to come back here. I'm going to break down 625 into 5 to the 4th. Now again, I'm looking for perfect cube. So break 5 to the 4th into cube root of 5 to the 3rd times 5 to the 1st. Now if I have to do a middle step, let me just circle the perfect cube here. So if I have to show the middle step, this is same thing as cube root of 5 to the 3rd times the cube root of 5. So now this whole thing's going to become just 5, and then cube root of 5 remains. So that's going to be our answer. All right, now let's take a look at the fourth root. So let's try fourth root of 243. So what we're looking for now is the perfect fourth. So let me see, 243. I'm gonna break it down. So here 3 is gonna go in. 3 times 81. 81 is 9 and a 9. 3, 3, and a 3 and a 3. So it looks like 243 is 3 to the, how many 3s do we have going on? 1, 2, 3, 4, 5. 3 to the 5th. So now I'm going to come back here. I'm going to break this down into 3 to the 5th. Okay, but now what we need to do is break 3 to the 5th into 3 to the 4th times 3 to the 1st. Because what we're looking for is the perfect fourth. So this is going to be the same thing as, you don't have to write this step out, but fourth root of 3 to the 4th times fourth root of 3. And this is just going to become 3. So we're going to have 3 times fourth root of 3, and that's it. That's going to be our answer. Hopefully you're kind of getting the hang of it. Let's just do another one. A, B, C, D, E, F, G, H. Okay, so maybe fourth root of 729. Okay, so pause the video and try this on your own. Why am I pausing? I always do that. Okay, so I'm going to pretend that you stopped the video and try this problem on your own. So what I'm going to do is break down 729. All right, let's take a look. Sorry, I'm just gonna write this a little bit darker. All right, so what goes into 729? Well, 3 is gonna go in, I think. So 729 divided by 3 is 243. And I think 3 is gonna go in there again. So 3 times 81. And 9, 9, 3, 3, 3, and a 3. So it looks like 729 is 3 to the 1, 2, 3, 4, 5, 6. 3 to the 6. All right, so now I'm going to come back here. So we're going to have fourth root of 3 to the 6. Okay, so what are we looking for? Since we're given the fourth root, we're looking for perfect fourth. So I'm going to break this down into the fourth root of 3 to the 4th times 3 squared. All right, so then let me just circle the perfect one. This one's perfect. So I'm going to skip that middle step. I'm going to break this thing up into fourth root of 3 to the 4th times fourth root of 3 squared in my head. So here you're going to have just the 3. This portion is fourth root of 3 to the 4th. And multiplying here by the fourth root of 3 squared, which is just going to be 9. So that's it. This is going to be the answer. How did you guys do on this one? Don't worry, we're going to practice some more. Let's take a look at example 3. Simplify square root of x to the 3rd. Do not panic. Yes, you see the variable, but it's a lot easier than you think. Okay, so we're going to follow the same procedure. So since we're given the square root, what we're looking for is a perfect square. So I'm going to break x to the 3rd into x squared times x to the 1st, because again, we add the exponents. So now let me circle the perfect one. All right, so this is same thing as the square root of x squared times the square root of x. Now, I don't know if we remember this or not. If you're given the eventh root, this becomes the absolute value of x, not just x, absolute value of x. So here, I'm going to have absolute value of x times the square root of x. And that's going to be the answer. So in case you forgot about this from the previous section, so let's note. So if you're given nth root of a to the n, now this guy becomes an absolute value of a if n is even. And this just going to becomes a if n is odd. And that was from our previous section. That's why when you're given the square root of x squared, it's going to be absolute value of x. Let's do another one. Let's try square root of x to the 9. Okay, since again we're given the square root, what we're looking for is perfect squared. So here I'm going to have x squared times x squared. How many x's do we have so far? 4. And then another x squared. How many is that? 6. And then another x squared, 8. And then x to the first. Did I do that right? 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 1 is 9. All right, cool. So here we go. Now let me do the same thing. I'm going to circle the perfect square. Then this becomes the square root of x squared, square root of x squared, and then square root of x. Now, again, square root of x squared is absolute value of x. So how many absolute value of x are we going to have? Well, 1, 2, 3, and a 4. So we got absolute of x to the 4th times the square root of x. Okay, but now let's just look at that absolute value of x to the 4th. Well, do you see that no matter what the x value is, either positive or negative, if you put that in absolute value, it's always going to be a positive number. Now, positive number to the 4th power is positive no matter what. So here, in that case, you drop that absolute value and leave it as x to the 4th times the square root of x. So that's going to be the answer. Okay, so since we're going to have to do this eventually, let's just take a look at square root of x to the 9 again in a different way. Okay, so what is the biggest number before 9 that is divisible by 2? That will be 8. So here, I could break this guy up into x to the 8 times x to the 1st. All right. Now, do you notice something? So our answer was x to the 4th, wasn't it? And square root of x remains. So let me just write it as square root of x to the 8 times the square root of x. Now, somehow this guy became x to the 4th. So, do you see any kind of relationship? Given 8 and given the square root, which is 2, what do you notice? That's nothing but 8 divided by 2, isn't it? 8 divided by 2 is 4. So you can think of it in that way. So if you're given a square root, remember there is that invisible 2 sitting here. So if you break it up in this way, all you have to do is take x to the 8 divided by 2. So which gives us x to the 4th. Okay. Anyway, so let's look at part C, square root of y to the 15. So if I want to do this step by step, I'm going to have to break this down into square root of y squared, y squared, y squared, y squared. How many y's do we have? 2, 4, 6, 8, 10, 12, 14, and 15. So you're going to have that. That looks nasty, doesn't it? But you can do it this way if you like. But let me just try to do this in a different way. So here, what is the biggest number before 15 that is divisible by 2? That will be 14. So here I'm going to break y to the 15 into y to the 14 times y to the 1st. Okay, so now this is same thing as square root of y to the 14 times square root of y. Now, since there is that invisible 2 sitting here, this portion is going to give us y to the 14 over 2 times square root of y. So we're going to get y to the, what power is that? 7 and square root of y, and that's going to be our answer. Okay, now let's take a look at cube root of x to the 10. So again, you can break this up into cube root of x to the third times x to the third. How many x's is that? 6. X to the third, that's 9. And x to the first if you want to. Okay, or you can just think of it in this way. What is the biggest number before 10 that is divisible by 3? That will be 9, isn't it? So from here, I could just go cube root of x to the 9 times x to the first. And then we can break this up into cube root of x to the 9 times the cube root of x. Okay, so now, since we're given the cube root, this portion just gonna become x to the 9 over 3. And then cube root of x remains, so our answer is going to be x to the third times cube root of x. But you don't have to do it this way. You can just go directly from here. So this is same thing as cube root of x to the third. And then cube root of x. Now, sorry, I forgot to circle the perfect ones. So in this case, what we're going to get is x times x times x times the cube root of x. So we're still going to get x to the third times cube root of x for the answer. So either way you want to do it is okay. Now let's look at fourth root of x to the 10. Now if you want to use the shortcut, think of it in this way. What is the biggest number before 10 that's going to be divisible by 4? Well, I think that's 8. So here, what I can do is break this guy up into x to the 8 times x squared. So again, here what we're going to get is fourth root of x to the 8 times the fourth root of x squared. But this portion here now becomes x to the 8 over 4, and then just attach fourth root of x squared. So in this case, what we're going to get is x to the, what's 8 divided by 4? 2. And then fourth root of x squared. I'm not too picky about putting the absolute value around x or something like that. So on the test, if you forgot to put an absolute value, that is totally fine. You're not going to get marked off. But anyways, I'm just going to box that for the answer. Okay, now let's increase the level of difficulty just a little bit, just a tiny bit, but you got this. So simplify square root of 72x to the 7. So we got two things going on. We got a square root of 72 that we need to work on, and then also the square root of x to the 7. So what I'm going to do is I'm going to do the same thing. I'm going to break down 72 into a product of prime. So 72 dividing by 2 is 36. And 6 and a 6, 2, 3, 2, 3. So 72 is 2 to the third times, what is that, 3 squared? All right, but since we're given the square root, what we're looking for is perfect square. So here, I could even work it down, or here already. This is the same thing as 2 squared times 2 to the first, and then 3 squared. All right, but anyways, let me just write this guy as square root of 2 to the third times 3 squared. Now let's go with x to the 7. So I'm going to use the same trick as what we did in the previous example. What is the biggest number before 7 that's going to be divisible by 2? Because we're given a square root. So that will be 6. So here I'm going to break this off into x to the 6 times x to the first. Okay, now since we're looking for perfect squared, this is same thing as 2 to the second times 2 to the first, 3 squared, x to the 6, and then x to the first. Now let me just circle the perfect ones. Then I'm going to break this up into, you don't have to do this step if you can do it in your head. This is same thing as square root of 2 squared, square root of 2, square root of 3 squared, square root of x to the 6, and then square root of x. Okay, so this is same thing as 2 to the 2 over 2, which is 2 to the first. So this is just going to be 2. And let me just deal with the perfect ones. So perfect ones are this, this, and this. So square root of 3 squared is going to give us 3 to the 2 divided by 2. So you're going to have 3. And then x to the 6, this is same thing as x to the 6 over 2. 6 divided by 2. So in this case, we're going to have x to the third. And then the rest of it is square root of 2 times the square root of x. So putting it all together, we're going to have 6x to the third, and then combine the square roots together. Here you're going to have square root of 2x. So that's going to be the answer. Let's do another one. Let's go with the cube root of 54y to the 10. So again, I'm going to do the same exact thing as what we have been doing. So first, I'm going to break down 54. That's even, so 2 is going to go in. So 2 times 27. And then 3 is going to go in. So it's going to be 3 times 9, 3, and a 3. So it looks like 54 is 3 cubed times 2. And I think we're good to go. So let's break it down. So this is same thing as the cube root of 3 to the third times 2. Now let's deal with y to the 10. So what is the biggest number before 10 that's divisible by 3? That's 9. So I'm going to break this off at y to the 9 times y to the first. Alright, now let me circle the perfect ones. Alright, those are the guys who can get outside of the cube root. So what do we got? We have cube root of, let me just write it like this, cube root of 3 to the third, and then cube root of y to the 9, and then the rest of it, which is 2y, cannot get out of the cube root. So this is the same thing as 3 times y to the 9 divided by 3 times the cube root of 2y. So which gives us 3y to the third, 9 divided by 3, 3, right? And then cube root of 2y. And that's it. That's all we have to do. Alright, now I'm going to let you try this one. We have cube root of 128 x to the 11 y squared. So pause the video and see if you can do this or not. And don't get thrown off just because you see two variables, x and a y. Do the same thing for x and then do the same thing for y. Try it. Okay, so again, I'm going to assume that you tried it. So first, what I'm going to do is break down 128. Now that's even, so 2 is going to go in. So here, 2 times, what is that, 64? And 8, 8, 2, 4, 2, 4, 2, 2, and then 2, 2. All right, so how many 2's do we got going on? 1, 2, 3, 4, 5, 6, 7. So it looks like this is 128 is 2 to the 7. All right, but the thing is, I'm looking for perfect cube. So here, what I should do is break this down into 2 to the 6 times it by 2 to the first. Do you see why I broke it off at a 2 to the 6? Because notice that we're given the cube root, and 3 will go into 6 very nicely. But anyway, so let me rewrite. So this is same thing as the cube root of, let me just write it as 2 to the 7. And then now let's go with x. Now, what is the biggest number before 11 that's going to be divisible by 3? Well, that's 9. So break off point is 9. And then x squared is going to remain. And then y squared, well, 2 is smaller than 3, so we can't do anything about that. So we're just going to leave it the way it is. All right. Now, let me just go like this. So here you're going to have cube root of, now let's deal with 2 to the 7th. So here you can break it into, 2 to the 7 is 2 to the third times 2 to the third times, oh, not 3, sorry, 2 if you like. Or you can just think of it as, well, what's the biggest number before 7 that's going to be divisible by 3? Well, that's 6. So I'm just going to write it like that. And then x to the 9, x squared, y squared. All right, so now I'm going to circle the perfect ones. Alright, so then what's going to happen is here you're going to have cube root of 2 to the 6. That's same thing as 2 to the 6 over 3. And then x to the, so now I'm working on cube root of x to the 9. So that's same thing as x to the 9 over 3. And then rest of it is not perfect. So I'm just going to leave it the way it is. Alright, so this looks like it's going to get 2 squared times x to the third times cube root of 2x squared y squared. So it looks like we're going to have 4x to the third times the cube root of 2x squared y squared. And that's going to be the answer. Don't worry, you know me. We're going to do more examples. Okay, now let's try to simplify cube root of 56 x to the 5th y to the 20. We got this. Alright, so feel free to stop the video and you can try this on your own. And I'm just going to work on this one. So first, again, I'm going to break down 56 into a product of primes. So here, what do we get? 56 dividing by 2, so that's 28. And 2 is going to go in again, so you're going to have 2 times 14 and 2 times 7. So it looks like 56 is 2 to the third times 7. This looks good because what we're looking for is perfect cube number. So let me rewrite this as cube root of 2 to the third times 7. Now let's deal with x to the 5th. Okay, so now where's the breakoff point? What is the biggest number before 5 that's divisible by 3? Well, that's x to the third, so I'm going to write it as x to the third times x squared. Now let's go with the y. What is the biggest number before 20 that's going to be divisible by 3? I think that will be y to the 18th, and then here you're going to have y squared. Oh my gosh. Alright, sorry, I didn't mean to cross out that exponents there. Hopefully you can still see it. So now I'm going to circle the perfect ones. That's perfect. Perfect. That's perfect. Rest of it, you're not perfect. Alright, so let's deal with this. Ready? So we got cube root of 2 to the third. So that's going to give us 2. Alright, now cube root of x to the third, that's x. Now, cube root of y to the 18th is y to the 18 divided by 3, which is going to give us y to the 6. So I don't want to skip any steps, so here we go. Alright, and then here you're going to have cube root of 7x squared y squared. So here you're going to have 2x y to the 6 times cube root of 7x squared y squared. So that's going to be our answer. How you guys doing up to here? Hopefully you're getting hang of it. So let's try another one. Let's try 4th root of 80x to the 7 y to the 4th z to the 23. You got this. Pause the video and try this on your own. Okay, so first I'm going to break down 80. 2 times 40. 4 times 10, 2, 2, and 2, 5. So 8, that's a 5, sorry. So 80 looks like 2 to the 1, 2, 3, 4, 2 to the 4th times 5. Okay, so this looks great because we're looking for perfect 4th. And then we got 2 to the 4th going on. All right, now let's break it down. So we got 4th root of 2 to the 4th times 5. Now let's deal with the x. Where's the breakoff point? Well, what is the biggest number before 7 that's divisible by 4? Well, there's no such number except for 4, so I'm going to break it off for the x to the 4th. Then you're going to have x to the 3rd remaining. And then y to the 4th is already perfect 4th, so I'm just going to leave it. Now let's deal with the z. Okay, so what is the biggest number before 23 that's going to be divisible by 4? 20? What do you think? All right, so 20, and then remaining is z to the 3rd. All right. Now I'm going to circle the perfect ones. Perfect, perfect. Who else? Perfect, perfect. The rest of it, you're not perfect. All right, let's deal with this one then. So fourth root of 2 to the fourth is 2. Fourth root of x to the fourth is absolute value of x, but again, I'm not too picky about it, so I'm just put x if you like. And then we have fourth root of y to the fourth, so that's going to give us just the y. And then fourth root of z to the 20, so on z, the exponent is going to be 20 divided by 4, so this is going to become 5. And then the rest of it is fourth root of 5x to the third and then z to the third. And that's going to be the answer. How did you do on this one? I'm hoping that you're getting hang of it. We could do another one, so why not? Let's do another one. All right, let's try fourth root of 162 x to the 11 y to the 12th and then z to the 8th. So again, pause the video and try this on your own and see what you get. So I'm gonna start working. So 162, 2 goes in, 2 times 81, 9, and then 3, 3, 3, 3. So it looks like 162 is 2 times 3 to the 4th. Since we're given the fourth root, it looks great because we have a perfect fourth, which is 3 to the 4th. All right, now break it down. So we got fourth root of 2 times 3 to the 4th. All right, now let's deal with the x. Okay, so what's the biggest number before 11? That's going to be divisible by 4. That would be 8. And then who remains? X to the third. All right, now let's go with y to the 12th. Well, 4 goes into 12 nicely, so y to the 12th, I'm just going to leave it the way it is. And what about z to the 8th? That's 4 going to 8 nicely? Yes, so I'm just going to leave it as z to the 8th. All right, let me circle the perfect ones. Perfect, perfect, yes, and then yes. All right, so then here what we're going to get is, ready, fourth root of 3 to the 4th, that's going to become just 3. And the fourth root of x to the 8 is just going to become x to the 8 divided by 4, which is squared. And then, well, who's the next one? Y to the 12. So y to the 12 divided by 4, which is 3. And then z to the 8 divided by 4 is that, z squared. And the rest of it, we're going to have fourth root of 2x to the third. And so this whole nastiness is our answer. If you got this one correct, great job. And then if you made a mistake somewhere, make sure where you went wrong. That's the most important part. Okay, so now let's take a look at something a little bit different. Simplify square root of 80 over 45. Okay, so first, before we do anything, first notice that nth root of a over b is nth root of a over nth root of b. But even before that, notice that I could simplify the radicand a little bit because 80 and 45, I think 5 will go in. So first, I'm going to simplify as much as I can. So here, let me see. 80 is, what is that? 5 times 16. And then 45 is 5 times 9. You don't have to show this step, but I'm just showing everything step by step here. So 5 is going to cancel. So this is same thing as square root of 16 over 9. So now let's split them up. Square root of 16, square root of 9. So square root of 9 is 3. Square root of 16 is 4. So answer is going to be 4/3 or 1 and 1/3. Just going to box both of them for the answer. And let's look at the next one. We got cube root of 54 over 250. Well, can we simplify this a little bit? Simplifying the radicand, that's what I'm talking about. I think so, because they're both even numbers, so 2 is going to go in. So I'm just going to rewrite this as cube root of, you don't have to show this step, but let me see, 54 divided by 2 is 2 times what is 27? And then 250 dividing by 2, what we're going to get is 2 times 125. So we could cancel the 2's. So it looks like we need to deal with cube root of 27 over 125. Alright, so let me take a look at this. So we got cube root of 27, whole thing over cube root of 125. Okay, so I'm going to do the same thing. So if you can't think of the perfect cube, 27 is 3 times 9 and 3 times 3. So 27 is 3 to the third. Yay, that's a perfect cube. Now let's go with 125. That's 5 times 25, 5 and a 5. So this is 5 to the third. They're both perfect. Okay, so now I'm going to bring it down here. So this is same thing as cube root of 3 to the third, whole thing over cube root of 5 to the third. So our answer is going to be 3 over 5. Let's take a look at cube root of 24 over 375. Okay, so you don't necessarily have to simplify the radicand before you do this, but the length of the prime tree would be shorter if you reduce it as much as you can. But anyways, let's take a look at this. So we got 24, that's 3 going to 24, I think so. So that's gonna be, what is that? 3 times 8. And let me keep the cube root. Alright, and then whole thing dividing by 3 times, okay, I think 375 divided by 3 is, what is that, 125? Alright, so now, basically what I just did was divide 24 and 375 by 3. That's all I'm doing. So then, what we got? What we have, cube root of 8 over 125. Alright, so then, if you see this right away, that's fine, but 8 is 2 and a 4, 2 and a 2, so 8 is a perfect cube, and 125 is also a perfect cube because 5 to the third is 125. So first I could break down to 5 times, what is it, 25, and then 5 and a 5, so this is 5 to the third. So here we got cube root of 8, which is 2 to the third, whole thing over cube root of 5 to the third. So our answer is going to be 2/5. Okay, so suppose that I didn't see that 3 is going to go into 375 or something like that. You can still do it because, let me see, where can I work on? Okay, so 24 is 2 times 12, and then 2 times 6, and then what is that? 2 times 3. So it looks like what we're going to get is 2 to the third times 3. And for 375, well, I know for sure that 5 is going to go in. And 5 times 75 gives 375, I think so. Alright, now again 5 is going to go in. So 5 times, what is that, 15. And then 5 times 3. So this is same thing as 5 to the third times 3. Alright, so then we could just do it this way. So therefore, cube root of 24 over 375. This is same thing as cube root of 24 is 2 to the third times 3. And then whole thing over, let me see, what do we got? Cube root of 375 was 5 to the third times by 3. Whoops. There you go. Alright, so then I'm going to circle the perfect ones. So it looks like what we're going to get here is, well, cube root of 2 to the third is just 2. And then cube root of 3, whole thing over, cube root of 5 to the third is 5. And then we still have cube root of 3. Well, we can cancel these because this is the same thing. So your answer is going to be 2/5 regardless. Okay, now let's take a look at part D. Cube root of 24x to the 7, whole thing divided by y to the 9. So again, do not panic, just work one thing at a time. So let's first go with the 24. So the 24, oh, I just worked it right above that, but oh well. So 2 times 12, and then 2 times 6, 2 times 3. So this is 2 to the third times 3. All right, so now I'm going to break this into cube root of 24 is 2 to the third times 3. Now let's go with x to the 7. Just look at x to the 7. We're going to do the same thing as before. What is the biggest number before 7 that's going to be divisible by 3? Well, that's 6. So the break-off point is going to be x to the 6 times x to the first. Now whole thing over cube root of y to the 9. Does 3 going to 9 nicely? Yes. So I'm just going to leave it the way it is. Now I'm going to circle the perfect ones. All right, now let's do it. So this is going to be cube root of 2 to the third is just 2. Cube root of x to the 6 is x to the 6 dividing by 3, which will give us 2. And then the rest of it is going to be trapped under the cube root, which is just cube root of 3x. Now whole thing over, here you're going to have y to the 9 divided by 3. So here you're going to have y to the third. Since we don't have any common factors, so this is going to be the answer. Let's do another one. Fourth root of 80 x to the 10 all over y to the fourth. So let's do this. So 80, well, I can think of 8 times 10, 2 times 4, 2, 2, and then 10 is 2 and a 5. So 80 looks like we're going to have 2 to the, how many 2's do we have? 1, 2, 3, 4, 2 to the 4th. Is that right? Yeah, times by 5. Okay, so now I'm going to break this up into fourth root of 80 is now 2 to the 4th times 5. Now let's deal with the x to the 10. Okay, ready? What is the break-off point? Well, break-off point is going to be the biggest number before 10 that's going to be divisible by 4. So I believe that's going to be x to the 8. So the remaining is x squared. Now whole thing over fourth root of y to the 4th is already a perfect fourth, so I'm just going to leave it. Okay, so I'm going to circle the perfect ones. Okay, I think we're good to go. So what do we got? We have fourth root of 2 to the 4th, so that's 2. Fourth root of x to the 8 is x to the 8 divided by 4, which is going to give us 2. Then we're going to have fourth root of 5x squared. Now whole thing divided by fourth root of y to the 4th will just give us a y back. So that's it. That's all you have to do. So this is going to be our answer. Now let's look at something like this. Simplify that. Okay, so first thing first, remember this property. If I have a b to the m over b to the n, this is b to the top exponent minus the bottom exponent, which will be b to the m minus n. So keep that in mind. Now let's take a look at the radicand. Now focus on the x's. So we got, let me just circle this. We have x to the 5th over x. So that's same thing as x to the 4th power. Because if I have x to the 5th over x, that's x to the 1st. According to the property, this is going to be x to the 5 minus 1, which gives us x to the 4th. All right, so then let me just rewrite that before I forget. So we're going to have 18 and then 32. And then on the top, we're going to have x to the 4th. X to the 4th going to remain on the numerator. Be careful there. So now let's look at the y's. Y to the 7 over y squared. Okay, y to the 7 over y squared. Now that's same thing as y to the 7 minus 2, which is y to the 5th. So here what we're going to get is y to the 5th. Now let's look at 18 over 32. Let me see. You don't have to simplify 18 over 32 if you don't want to. I mean, you can still do this, but I see that 2 is going to go in. And what we're going to get is, let me see, square root of 9 x to the 4th, y to the 5th. Now whole thing over, 32 divided by 2 is 16. All right, here we go. Okay, now let's look at this expression now. So this is same thing as 9 is same thing as 3 squared. And then here you're going to have x to the 4th. And then let's look at the y. Now y to the 5th, well, you're given the square root. So what is the biggest number before 5? That's going to be divisible by 2. That will be 4. And then remaining is y. And whole thing over square root of 16. Oh, sorry, square root of 16, I already know that's 4, but this is the same thing as 4 squared. You don't have to write this step out if you already know that square root of 16 is 4 and then square root of 9 is 3. But anyways, so this is going to give us, let me just circle the perfect ones. Okay, so then here you're going to have 3x to the what power? 4 divided by 2 is 2, y to the 2nd, and then square root of y, now whole thing over 4. And nothing else cancels out, so that's going to be our answer. Okay, let's do another one. So we got cube root going on. Alright, so do not panic, we're going to do the same thing. So let's just first simplify the variables. So we have, let me see, this is same thing as cube root of 54. Now x to the 7th over x squared, this is going to give us x to the 7 minus 2, which is x to the 5th. So x to the 5th, and then let's look at the y's. So we have, let me see, y to the 5th over y squared. So here we're going to have y to the 5 minus 2, which is y to the 3rd. So we're going to have y to the 3rd. Now, whole thing dividing by 250. Now let's deal with 54 over 250. Well, I can see that 2 is going to go in, so 54 is 2 times 27, and then 250 is 2 times 125. So I can cancel out the 2's, so it looks like we're going to have 27 over 125. Okay, so now let's go with the 27. Now I'm going to break down 27. 3 times 9, and then 3 and a 3, so 27 is 3 to the 3rd, and 125 is 5 to the 3rd. We did that earlier. Anyways, let me rewrite this. So we got cube root of, well, 54 over 250 became 27 over 125, so I'm going to have, I'm going to have 27 x to the 5th, y to the 3rd, whole thing over 125, which is cube root of 3 to the 3rd times x to the 5th. Okay, so let's break that up already. So where's the breakup point? Well, what's the biggest number before 5? That's going to be divisible by 3. That will be 3. And then remaining is x squared. And then y to the 3rd is a perfect cube, so I'm just going to leave it the way it is. And then now here we're going to have cube root of 125 is 5 to the 3rd. All right, I'm going to circle the perfect ones. Okay, so then I'm running out of room. Okay, so then this is going to be cube root of 3 to the 3rd is 3. And cube root of x to the 3rd is x. And then cube root of y to the 3rd is y. Now whole thing, oh, sorry, I forgot the cube root of x squared. And whole thing dividing by 5. And that's going to be the answer. Okay, next example, let's take a look at something a little bit different. Simplify 8 plus square root of 96. Okay, so first I'm going to break down 96. Okay, 2 is going to go in, well, 3 is going to go in as well, so let me just break down with 3. And then we have 3 times, what, 32? And then 2 times 16, 4 times 4, 2, 2, 2, 2. So how many 2's do we have? So we have 1, 2, 3, 4, 5. Oops, sorry. 2 to the 5th times by 3. All right, so then let's just rewrite this. I'm going to do this step by step. So here you're going to have 8 plus square root of 2 to the 5th times by 3. That will give us 96. Okay, now let's break up. So I'm just going to keep dropping down the 8. Now let's, since we're talking about the square root, let's break this off into 2 to the 4th times 2 times by 3. All right, now I'm gonna circle this one because that one's perfect. And now let me just go one more step. Here you're gonna have 8 plus. All right, now let's look at the square root of 2 to the 4th. So where can I write the square root of 2 to the 4th? That's same thing as 2 to the 4 dividing by 2, which gives 2 to the 2nd, which is gonna give us 4. So here we're gonna have 4 times the square root of 2 times 3 is left over, which is going to be 6. So that's going to be our answer. This is a common mistake. Remember the order of operations. That 4 is stuck to square root of 6, not to 8. So you cannot make this into 8 plus 4 multiplying by square root of 6. Meaning this does not equal to 12 square root of 6. That's what I'm trying to say. Just in case, I'm going to write that this does not equal to 12 square root of 6. No. All right, so then let's do another one. Let's look at something like 3 plus square root of 90, whole thing dividing by 3. All right, we got this. So first what I'm going to do is break down the 90. Okay, so 9 times 10, 3325. So here you're going to have 3 squared times 2 times 5 will give us 90. So let me just rewrite it. So this is same thing as 3 plus the square root of 3 squared times 2 times 5. Whole thing dividing by 3. Alright, now let me just keep simplifying the square root. So this guy is perfect. So what we have left is 3. I'm just going to trail down the 3 plus. Now square root of 3 squared gives 3. And then rest of it is square root of 2 times 5, which is going to give us 10. Whole thing dividing by 3. Alright, so remember this property as well. Remember if you have a plus b all over c, this is a over c plus the b over c. So break it up. So this is same thing as 3 over 3 plus 3 root 10 all over 3. So then this is going to cancel out to 1. Cancel out to 1. So our answer is going to be 1 plus just the square root of 10. So that's going to be the answer. Alright, let's do another one. Part C, 15 plus square root of 75, whole thing dividing by 5. Alright, so pause the video and try this on your own and see if you can do this or not. And meanwhile, I'm going to work it. Okay, so I'm going to break down 75 as we always do, 75. So for sure, 5 is going to go in. So we got 5 times, what is that, 15? And then 5 times 3, so it looks like we have 5 squared times 3. All right, so then I'm going to rewrite. 15 plus the square root of 5 squared times 3, whole thing dividing by 5. Circle the perfect one. So then this is going to become, that's an equal sign, sorry, 15 plus square root of 5 squared just gives us 5. And then the remaining is square root of 3, whole thing dividing by 5. One more step. So break it up. 15 over 5 plus 5 square root of 3 all over 5. So it looks like 5 goes into 5 once, into 15 3 times, and 5 is going to cancel. So looks like our answer is 3 over 1, which is just 3, and then plus the square root of 3. How did you do on this one? Hopefully you're becoming one with the radicals. But anyways, I'm going to stop here. And if you did all these examples with me, good job. And again, if you have any questions, please let me know.